Welcome to Cyberwatch Finland's studio. And we are here today to discuss about the OT security. I am Aapo Cederberg and the CEO of Cyberwatch Finland. And I'm happy to moderate this discussion. And this discussion is going to be hosted by dedicated network partners. And I have the pleasure to introduce Antti Viro. Please, Antti.
Yes, thank you. So my name is Antti Viro. I'm from Dedicated Network Partners as a Chief Technical Officer there, and I'm here to talk about you a little bit about the operational technology networks and also the cybersecurity, what is related to the OT today.
Thank you, Antti. And then we have with us two high-valued experts on this topic. So Hanna Pikkusaari, please, you have the floor.
Yeah, so my name is Hana Pikkusaria and I work for Osaango as a smart tech advisor. Most recent responsibilities have included operational and property technology and IT-related change program leadership, continuity, and enterprise architecture.
Okay, thank you, Hanna. And then we have Ivo Maritz from Switzerland and MSF Partners. Please, Ivo.
Hello, my name is Ivo Maritz. I'm from formation, I'm a civil engineer from ETHZ. I have then been an assistant and scientific collaborator in computer science at the University of Bern, and since then I was always in IT, in leadership functions in different industries, and also as a CTO and a COO in a Swiss telecom carrier for business to business. My last occupation before joining MSF Partners as a senior consultant was CIO and then as Chief Security Officer, Chief IT, and if the term would exist, Chief OT Security Officer of BKW.
Okay, thank you very much, Ivo. And so we see the OT security is a complex issue, and perhaps we start with the definition. So how should we define? Because I have a feeling that OT is having an utmost important in cybersecurity, because we have the critical functions of the society, we have the critical services, and there's a super critical element in that is OT security. So Antti, how do you define OT security?
Well, I would say that first you need to understand what is really is the OT, and then to see, okay, what is the cybersecurity for that. So the OT is really something like it says operational technology, so it's a control for something. It's not the information itself is not important, it's that the control what happened. So for example, traffic light is good example for that. So if someone can get your message where you control your traffic light, it does not harm a lot or nothing. But if someone can send a fake message to your traffic light, it should be red, but it sets message green. Crash happen. Or then someone just blocks your traffic light, it's not showing nothing. Okay, then the traffic could go, but slowly there might be accidents. So that's like the operational thing, that it controls something else, but it's very critical, and that sense, this system must be protected also from the cybersecurity point of view.
Okay, that's a good example, and as we see in your example, so actually why the OT is so critical, it is because of the consequences. So it's not a cyber incident, but it's the consequences which you can create through hitting to the OT security. So Hanna, how sounds this to you? How do you define OT, or are you in line with Antti's definition?
Very in line with Antti's definition. So I would say OT is the technology beyond IT. So it's kind of hidden technology that we can't see, and we probably don't think that about its existence, but it is there. And in the built environment, it's an enabler actually for IT and for any business, because it runs the buildings that are running the servers, like the server halls. And when it comes to built environment only, it's an extremely complicated environment running the heart and soul of building and providing opportunities for ecosystems like smart cities. But I like that traffic light example. It's a good one. And about the security and safety in OT environment versus IT, like the prioritization is different, because in IT you can easily put the systems, in order, but in OT environments there is life and safety always to be considered, and it's always about like the timing and who or what is in the building or in this environment, and then you know what's the prioritization of that certain time of the system.
So listening to you can we also see that OT is actually a gateway from the digital world to the physical world. The attack is digital, but then the consequences can be physical. Is that really why this is so scary?
It's not scary, but it's interesting.
It's a challenge. Okay, Ivo, how?
It's a challenge. Yeah, it's a challenge. It has to be seriously addressed, and I like what I have heard. This is absolutely in line. I would just like to add all the manufacturing lines to the building, which are also mostly controlled these days by computing. Computing everything that has a CPU in it. And I like the approach of the Purdue model, where we have two top levels which represent IT, the gateways to the internet, and then the usual IT servers and clients. And then we have going down, we have a demilitarized zone between IT and OT, and then we have the three OT levels. The top one, number 3, hosting the manufacturing execution systems and so forth. That is still realized in IT technology, but already part of OT. And then on the next level 2, we have things like SCADA, human machine interface, engineering workstations. And in level 1, we have the programmable logical controllers, remote terminal units, or whatever you call them. And on level 0, the physical level, we have the sensors and actors on the machinery or the building themselves. And machinery can be everything from power generators to building controls, to transformers in power distribution, to manufacturing lines of whatever is manufactured in all the different industries. And as Hana said, it's usually the things that are hidden from our eyes, but which make sure that very critical and less critical things work. And as we have learned during this corona pandemic, the automation and distribution of labor around the world has become so specific that all these parts are critical to our global supply chains. So we better take care about the protection, detection, and reaction against cyber attacks of these OT environments.
So we see that it's a complex issue to protect the OT. It's not just one device. It's not just one solution. It's a row of right step to the direction. So then you can build the OT security. But Antti, who should be worried about OT security? Who is having OT? Is it around the society, or is it just can we pinpoint the companies who are running the OT? So why should we be worried about?
Well, okay. One thing is as they stated in the discussions that it might affect to everybody. Like in building automation, that will affect to all the people who are living in the building. But they really cannot affect for that one. They are just the users. So the group of the people who can really decide and whose choices will make a difference are very limited. So that they are mainly companies or people who are taking care of these kind of automation systems, power grids, railways, everything else where this kind of critical OT is needed. And also having to say that that's very important, these DMTs and other interfaces between the OT and IT. But also one thing to have to remember is that many times, especially the critical OT systems, are much larger than just in the one individual building or industrial plant. It could be like a countrywide system. Like for example, power grid, it covers typically the one country, and that's like the one system, and one OT system must take care of all the this big area. And it means so that then the telecommunication is then important, how to send the communication channel between this the northest point of Finland here to the Helsinki, how to control reliability data between these 2 points. And okay, I'm telecommunication guy, so I like to talk about that one, but it's still it's important thing. And that sets also the requirements for the telecommunications, how reliable is that, like the classic reliability, but also the cyber reliability, so how well it's protected against the cyber threats. Because the availability of these kind of services is very important. And so that like in the classic way of thinking, reliability rules is okay, you have to set the redundant components, maybe the redundant paths, good planning, but there must be now added the cyber awareness, how to protect this from the cyber attacks, this the same system. So it is getting the more difficult because there are more things to understand. And that also leads like the classic reasons why to build like a dedicated network, separated network, for example, from railway signaling system. Was these classic reasons, but now there are also these cyber reasons. So can any service provider give you like a 100% availability? Like what if they want to patch the cyber patches to their system? There will be the downtime when they will do it. Everything, is it on your control or if it's some third-party control? And if you are using some encryption, authentication, keys, methods, how to make sure that it's like the end-to-end protected if everything is not on your own hands. So it goes to that direction that these, like the, let's say, the ultimate critical services, they are still keeping everything in the totally separated, like air-gapped systems, like they used to be in the past for different reasons, but now they are the new reason coming from the cybersecurity side.
If I understood you correctly, so you prefer to have a separate communication system for the OT security, so it shouldn't be connected to the internet, and the remote access can be a danger. And we as analyzing the cyberspace, of course, we see the development that actually the most scary and perhaps the most growing sector in the cyber threat is the cyber sabotage. And then the cyber sabotage guys who want to harm to our societies, they are really looking OT, and they are really looking the supercritical points in the societies. And there we always see the OT devices. There we see the OT system. And as you described, they are interdependent, so it can be countrywide, it can be Europe-wide, as Ivo said. So this is really perhaps why the challenge is growing all the time. And then it comes to my mind, and perhaps this is a question we can point up here. So who is responsible? Me as a citizen in Finland, listening Antti now here, so I become worried. So really my trains they can go to the wrong direction, or my electricity can be harmed with the cyber attack to the OT system. So who should take the lead and who should have the responsibility? Hanna, do you have a good solution for this?
Well, I would say that from building perspective, the building owner and the property owner and the managers, the management team that is managing the continuity in the building, they are responsible of that like that in whole that's a whole system. But in like a society, it's really a challenge, because we do have like I would say we do all the time we get more kind of smart systems on top of this whole system environment. And the smart systems may be smart office systems or smart building systems or smartish systems. And all these systems, when you buy them and you start using them, you maybe don't know that the one who implemented the system may have integrated this system to another system, and then you already get integrations maybe between different network segments. And then my favorite example is fire alarm system that is running many other systems in the building. So when you in a construction project just buy a kind of a small system and network environment for this fire alarm system, you may not know that it will be integrated today in many other systems and maybe many other clouds. So that's interesting, and in my opinion, the building owner and the construction project owner are the responsible of the environment.
So listening to you, it comes clear to me that okay, the owners, the private sector who is running the critical functions of the society, they should be responsible. They should understand. We speak a lot about the principle secure by design. So OT security should be taken into account when you start building new devices, when you start planning new critical infrastructures. Then you should take into account the cyber threat, and then it goes to the right direction. But we have a lot of legacy systems in our societies, and I think OT is there. So what about the legacy systems, Antti? What is it different with the new what we are designing, or how can we handle them?
Well, yeah, sure, they are different. But first of all, I have to say that you don't have to be worried, as you said, you be worried as a citizen. So I would say that no, you don't have to be. So, for example, railway networks, power grids, they have all been there, like OT systems, and they are very secure design already, decided many years already. And now the cybersecurity is something new that has come top of that, but they are the cool principles. And that's how, when keeping it the same way, separate devices for the OT purposes, then adding these good cybersecurity practices is like very easy to do it on that way.
Okay, thank you. Ivo, you have been modernizing the Swiss energy
Yes.
networks and systems. So is these principles applicable in Switzerland?
Absolutely. And actually, I liked our approach in Switzerland. There is I never remember whether it's the energy law or the electrical power supply law. There is just one sentence in the law which makes which makes the operators responsible. And responsibility goes from the top to the bottom. Everyone on all management layers, from the board of directors, executive committee, the division heads, the department heads, the team leaders, and the individuals are responsible within their field of responsibility. Otherwise, it doesn't. That's one important thing that you have to stop in all organizations. That people don't want to take responsibility for what they are responsible for and try to delegate it up the ladder or down the ladder. No, everyone in his field of responsibility is also responsible for cybersecurity. That's where it starts. And then you have, of course, to educate everyone so that they can and train them so that they really can take their responsibility and know what they have to do in this new field, from properly implementing things, properly operating their environments, and of course also, especially when they renew them, also make sure that the suppliers in the supply chain are aware of their responsibility, and that's also something new in the supply chain. These manufacturers of these control systems, in the past, they have built them and put the firmware onto whatever controller for the day of the delivery. And then this was shipped and was operating for 5, 10, 15, 40 years untouched. And people have to understand that the responsibility is not for the day when today this doesn't work anymore. The responsibility goes throughout the full life cycle. And also the supplier has to make sure that he still is able to support old firmware releases and patch them, and has to introduce the vulnerability and patch management process with all his customers. In IT, we have learned that down to most individuals that do their daily or weekly or at least monthly software update cycles even on their private computers. But on the OT side, the manufacturers and the end clients have still to learn that. We are there at the beginning. Maybe we have reached something between 5 and 15% of maturity, and in some critical infrastructure sectors, maybe 30 to 50. But we have still a lot to do there.
Okay, thank you very much. So it's shared responsibility. So there is not just one who is responsible in the companies, and of course then we have to look
at the end. Of course, it's the boss, but everyone has to take his part. The boss cannot do everything on his own.
Exactly, of course. The directors, they have the responsibilities, but then you pointed out the important thing. Human beings. So is it, Hanna, the same way in OT security, like we say in cybersecurity, in overall situation, that it's the humans who create the problems? And of course, we know the famous Stuxnet case when just a memory stick was taken into the OT environment and the damage could be caused. So what is the role of the humans here, Hanna?
That's a big role, and I like that Ivo pointed out this learning and teaching process, because like in all the levels, we should understand that this is a part of bigger solution and bigger architecture. So a human is the key for the solution, and also maybe for the causes some threats.
Yeah.
That's good and but thinking about the OT, I think we are much better positioned than on the IT because the people who are using these OT devices, they are always like authorized, trained, so it's not that kind of everyman's devices where a lot of risk because people are doing something that they really don't know what to do. So on the OT are safe on that sense.
So it's more isolated and you know who is running and who is doing what, so it's easier to audit and give the permissions.
Yeah, it's easier to control and the number of the people are limited who can access.
You're right and wrong at the same time. There is a good. I fully agree. It's limited people. It's limited access. It's a great safety culture, but an IT cult at the part of the IT culture that, despite the fact that these poor guys have to live, as I pointed out, with life cycles of 15 and 40 years, whereas in IT we exchange everything every 3 or 5 years. But still, the new way of IT technologies flowing into those OT environments, with all the pros, but also all the cons, especially that firmware is usually 85% of the firmware is usually taken out from open source from somewhere, and then you add some of your own modules that you program yourselves, and that's your firmware, and there you have, of course, a lot of vulnerabilities built in that only get discovered over the life cycle, and you have to fix that over the life cycle, and to get that way of thinking and behaving into these OT people is not obvious.
Okay, Hanna, you had a comment here, so.
Yeah, actually, in one building, like one office building, medium-sized, you can have dozens of systems somehow integrated, and then you can have tens of thousands of IoT devices, and then you can have several different network segments. So there is a lot to do, and it, like Ivo said, it's a challenge, and that's why we have to understand it like horizontally. I would say that running operational technologies a lot like, or it's mostly risk management, because you have on some level you have to understand the dependencies, and of course one person can't understand all of it, but you have to have a good team running the environment. And I've been wondering why is there in IT you can have like 300 persons in an IT team, and you have IT support and IT managers and IT directors, many of them. And in OT environment, even though you have dozens of systems and tens of thousands of IoT devices, you don't have a one OT manager. Why is that? Why is it outsourced totally, even though the responsibility is in its users?
Well, I think Hanna and Ivo, you are both pointing to the same direction. So it's that because the way of thinking for the OT has been like this: install and forget. So there are no need to do any maintenance for that after the installation. So no need to people for that, and no one is really thinking, okay, we might load some security patches also for these devices. So it's really change of thinking.
It's really a change of thinking. And interestingly enough, Hana, yes, you're right. They sometimes lack personnel compared to IT, but it starts earlier. It starts. Their safety culture leads them to block things, and here you have to learn and to adapt. And if you learn and adapt and put in, I give you an example. You have a network of in a manufacturing plant. You have a SCADA system or whatever you want to call it. Then you have your PLCs controlling your robots or whatever, and you put in. And in the usual way, you do the maintenance there and checking. You have to go from device to device, hopefully at least once a year. You have to plug in your laptop. You have to read out some parameters online. You have to then fill it into an Excel sheet. And that's your inventory and your firmware inventory. If you put in a modern OT security monitoring solution, you do get that on the fly every day and every hour, so you don't have to walk around and do this clumsy work. And you gain capacity there to do other things, but you have first to understand that you have to do that and to be open to and willing to accept that the world is changing. So again, it needs all three components. It needs the human beings, it needs the processes, and it needs technology, but it all starts and ends with the human beings and their culture and their understanding and their education and their training.
That's a very good point. We were discussing with my colleagues that what is smart building? How do we answer when somebody asks us, is this or that building smart? Then we understood that you have to have a right kind of mindset. Then you can make smart choices. Then you can purchase smartly and implement smartly. And
impose rules on your suppliers.
Indeed. And then you have smart contracts. Then you can have smart maintenance and like smart processes, but it's the whole circle. It's not only that you buy one system with AI in it. That's not smart.
Exactly. Fully agreed.
Okay, so to conclude, I can come to my favorite point that I see how to build cybersecurity. You have to be able to select your priorities and be smart and do the right things, small things, and then you can create a big thing. And I think the same goes with the OT. So you have to look the complexity, and then you have to solve the problems, and then you really can be on the top of your problem and solve them all. So small things create a big thing. So that's what is cyber. Okay, I thank you all. We have had a great discussion, and I can see that 20 minutes was a little bit limited. We could have been discussing this for hours. But this is a good start, and let's continue. And thank you very much for joining us today, and we are looking forward to working together again. Thank you.
Thank you very much. Bye-bye, everyone.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.